Hello everyone, welcome to today's webinar. My name is Randy from Element 14 and I'll be your host today. Today's presentation is from Texas Instruments and it's entitled 5 Things You Need to Know About Bluetooth 5. This webinar will be presented by Olivier Monnier. Olivier is the Director of Marketing for TI's Wireless Connectivity and IoT Solutions. Prior to this role, he spent 14 years in various positions including TI's Worldwide Smart Grid Marketing and Business Manager. At the end of the presentation, there will be a Q&A session. You can ask your questions in the Q&A window of the WebEx screen. So let me hand it over to Olivier for today's presentation.
Thank you, Randall, and good morning, everyone. Today we'll talk about an exciting thing about Bluetooth Low Energy, and more specifically about Bluetooth 5. And we're going to see how we can actually start right now Bluetooth 5 development with the Texas Instruments BLE solution. All right, so wireless connectivity is very popular for many applications in the industry. And in particular, Bluetooth Low Energy is very appealing to connect to a phone or a tablet. Traditionally, BLE has been used for smartwatch, wearables, audio, home electronics, but now there is a big push to adopt this technology in industrial and automotive. It goes with a couple of challenges, and we're going to see that Bluetooth 5 is addressing those challenges. For those people who might not be familiar with Bluetooth, this is the landscape of the Bluetooth technology. Bluetooth is an established standard driven by the Bluetooth Special Interest Group, the SIG Alliance. And we can see that we have historically Bluetooth Classic, which is more oriented around audio application or streaming audio with a throughput up to 3 megabits per second. It exists today in all phones and tablets and laptops. And then starting with the Bluetooth 4, the SIG Alliance released the Bluetooth Low Energy profile with more custom profile targeting lower power applications, and also now moving to higher bit rate. And in between, you have what we call the Bluetooth dual mode, which is a mix of classic and low energy. So today we will focus on the Bluetooth Low Energy. So the overall trend for the industry for Bluetooth Low Energy is, so everybody has a phone, everyone has a tablet, and we obviously see the benefit of being able to interface with a smart display like a smartphone. And the overall trend is that we are moving for Bluetooth Low Energy from connectivity around the human body, what I call the personal area network with a smartwatch, smart bands, and the phone and the laptop and so on, to more what we call local area network or house coverage. And that's the next step for Bluetooth Low Energy. A couple of challenges which are associated with that is speed, range, low power, and also coexistence inside the noisy 2.4 gigahertz frequency band, and also against other BLE devices. And precisely, in order to facilitate the adoption of Bluetooth Low Energy in industrial, Bluetooth 5 is solving some of those challenges. So now if you look deeper into the Bluetooth 5, really three key points that we will go more into details. Bluetooth 5 is addressing a new type of range with 4 times the range compared to Bluetooth 4, 2 times the speed, and also a huge increase in terms of message capacity. And we will give an example with beacons. So this slide is extracted from the SIG Alliance, and you have the reference here where if you want to go to the Alliance website to get more information. So if you look at the overall evolution of the Bluetooth Low Energy specification and features, so today we are at Bluetooth 5. Last year we had the Bluetooth 4.2, and you can see the overall improvement in terms of either speed or multi-role starting from the Bluetooth 4.1. In terms also of security, with secure connection and privacy already introduced with the Bluetooth 4.2 and carried over with the Bluetooth 5. And what we will go more into details is how do we achieve higher speed and longer distance and advertisement extension. So first, let's put in perspective what could be the benefits of having longer range, advertisement extension, and also higher speed for industrial application. So let's have a look at a building automation application with a door lock, for example. We can see here that we have a house with what we call a smart door lock that gives the user the ability to close and open his door or to control a lock using his phone. And simply, it's a very simple example, at the house level, Bluetooth 5 is giving you 4 times more coverage inside your home, enabling the user to reach the lock wherever it is, depending on the floor it is. So this simple example is showing that if you can increase your range, well, you can maybe optimize your system by removing repeaters and integrate Bluetooth Low Energy in a more reliable way into a smart home system. One of the benefits also at the design level is as long range enables a more reliable coverage, there is less retransmission needed, and therefore it contributes also to a lower power goal, so you save on energy. So leading with this example and expanding to other applications that could benefit from the same application, from the same benefits, if you look at appliance, HVAC, industrial sensor, long range will provide a more reliable building automation coverage and also provide an improved noise immunity into the 2.4 GHz space. So wider tracking zone, improving coverage, and we'll give you 2 examples, live examples that you can reproduce in your lab using our software and tool. The second improvement that we discussed for the Bluetooth 5 is the advertisement extension. So, and it's basically very useful for beacon application. So advertising extension essentially means that the beacon is transmitting more information. We move from 31 bytes to 255 bytes. More information means more personalized experience for the user, like for example, a more precise locationing function. And also, a BLE connection traditionally works with a handshake mechanism from the beacon to the receiver. With Bluetooth 5, the beacon can always send information without the handshake. This is called connectionless beacons, and this enables to send richer information quicker. So by extension, we certainly see the usage today deployed of beacons in airports, stadium, to do tagging system and tracking system. We can see that this will continue to be improved moving forward to do more intelligent ascent tracking and indoor navigation systems. Last, on the faster data transfer or the high-speed mode, looking at the chat here. All right. Still hear me? Good. So high-speed mode essentially will benefit many applications into the industrial space. The high-speed mode will improve the overall power consumption because you have less airtime, shorter airtime. You will give the user the ability to exchange more information faster. So we start to see already the benefits of the high-speed mode to do data logging or diagnostic into industrial application. You can do also faster firmware upgrade. So many other use cases are possible and are still to be discovered, but definitely the Bluetooth 5 high-speed mode feature is going to open the door for more innovation. And here, just speculating, as long as you can exchange more information, it can open biometric application, you can improve the security by reducing the latency by exchanging information, and simply also by improving the overall user experience. So many options, and we're going to see how it is done with the new standard. So moving on to looking now at the technical details. So let's have a look first at the higher speed. So typically for the high-speed mode, Bluetooth 5 is introducing now a 2 megabit physical modulation format here compared to the 1 megabit per second physical layer for the Bluetooth 4.2 and backwards. combined with the data length extension, which was introduced in the Bluetooth 4.2 for the core specification, the 2 megabit PHY will increase the net data throughput to approximately 1.4 megabits per second. So 2 times the throughput compared to Bluetooth 4.2, and developer will be able to change it dynamically. This new 2 megabits per second mode is also backward compatible with the previous existing standard BLE 4.2, 4.1, 4.0. And as we mentioned, one of the key benefits is that it will reduce the overall current consumption because the active radio on-air time is shorter. So new specification on the physical modulation format enables higher speed for Bluetooth 5. On the advertisement extension, so it improves basically the beacon application. So Bluetooth Low Energy typically relies on 3 advertisement channels to serve as what we call meeting points for devices that either want to pair or set up a connection, or simply want to broadcast or observe limited amount of information. So when we increase the number of BLE-enabled devices, those advertisement channels are becoming increasingly congested. At the same time, there will be a need to exchange and broadcast more data as we move to more Bluetooth Internet of Things oriented application. In addition to that, the new long-range physical layer that we will talk about in a few seconds, it will take up to 8 times longer to transfer the necessary information to set up a connection. So basically, the advertisement extension will also be mandatory in order to establish the connection into long range. So the solution which is implemented into the Bluetooth 5 is to offload the advertisement channel by using the 37 data channel to transfer and transmit the advertisement payload. So typically in a traditional BLE advertising, the same advertisement payload is sent on the 3 channel. Now with the extension, go back here. Now with the extension, there is only a pointer which is transmitted on the 3 advertisement channel, and then the pointer reveals where and when the actual advertisement payload is transmitted. And then the actual advertisement is then transmitted only once and on 1 data channel. So this reduces the overall load on the advertisement channel significantly. So improvement on the beacon and also a necessary function to establish connection for the long range. Another improvement on the Bluetooth 5, which is not really advertised but which is there into the standard, is now the frequency hopping, random frequency hopping that provides a more robust connection. Bluetooth Low Energy 4.x channel hopping is typically based on hop increment, which is a number between 5 and 16, meaning that you have only 12 different channel hopping patterns available. With the Bluetooth 5, this is replaced with a pseudo-random sequence with a guaranteed minimum frequency separation between 2 consecutive connection intervals. So this will increase the overall resilience to interference. Basically, it makes the connection more robust, and it will decrease the likelihood of nearby Bluetooth Low Energy devices transmitting on the same RF channel at the same time. So it provides more noise immunity against other BLE channels, which are more and more popular into our industrial environment. Now, if you look at one very promising improvement for Bluetooth 5 is the long range. So Bluetooth 5 basically introduces a new transmission techniques to achieve longer range without changing the basic modulation parameters. So in Bluetooth 4 Low Energy, you have one symbol of 1 megasample per second, which carries a bit stream of 1 megabit per second. If any one of those received bit is wrong, the whole packet has to be retransmitted. This is not a problem for short-range communication, but it limits the system for the system performance if you need longer range. So what is new on the Bluetooth 5 is two new available data rates, which are related to two new coded PHY with data rate at 500 kilobits per second and 125 kilobits per second. So you have two new data rates available as a coded variant of the 1 megasymbol per second physical format. So depending on the forward error correction that you use, 1/2 or 1/8, you basically have 500 kilobits per second or 125 kilobits per second. So typically, and we're going to see that more in details, when you combine with the 1/8 coding scheme, it improves the receiver sensitivity significantly. And this is one of the key improvements that the Bluetooth 5 is providing to improve the receiver sensitivity. And for all the data rates, the overall current consumption in receive mode is the same as the standard Bluetooth 4.2 or 4.x compared to the 1 megabit per second. So in other words, you are able to increase the range, multiplied by 4, without increasing the power consumption. And that's one key point of the Bluetooth 5 standard. More information can be found on the Bluetooth 5 standard. If you want to go more into details and answer all your technical questions, we also have blogs which are located on the TI website. So here we are still high level, give you a glance of how the new things are done. And the key point is new coded PHY with no change on the power consumption for the receiver side. In terms of conformity to the standard and improvements, we will see in our example that we have been testing and validating the long range since a while now, working very closely with the SIG Alliance. We have a very flexible radio in our family called SimpleLink that ensures flexibility for future software updates. And our radio actually supports for the future even up to 5 megabits per second in a proprietary mode or maybe future standard. So the key point is that we have a solution today that you can enable to test the long range right now. So let's go more into the details on what we have been testing from our side and what you could actually reproduce. So maybe you saw this video already, but back in December, we did test with outdoor line of sight, 1.5 kilometer with Bluetooth 5 using our device, and I will talk more about the device later on, which is called the CC2640 R2F, which is the latest technology for the SimpleLink Bluetooth Low Energy. And we did test 1.5 kilometer, and you have a nice video on the training.com from TI and also blogs that explains how we can achieve that. But I'd like to go more into the details here. So the Bluetooth 5 enables to do such a long distance also by improving the overall link budget. So if you go more into the details of the theory, the RF link budget is typically the ratio between the transmit RF power and the receiver sensitivity level. So based on that, you can see two ways to improve the link budget. Either you can increase the output power, so this will have an impact on your current consumption. And I will give an example later on where the typical numbers for power consumption are given at 0 dBm. If you do this, so you increase your power consumption and data rate is unchanged. Another option to improve the link budget is to improve the receiver sensitivity through the new coding techniques. And as we just explained with the new coded PHY, in this case, we have a data rate which is reduced with two new modes, 125 kilobits per second or 500 through the coded PHY. And but the benefit is that the current consumption is unchanged at the receiver level. So if you look at the sensitivity and the link budget, so if you look at the receiver side, the link budget is determined by this formula here. And if I take the example of the SimpleLink 2640 R2F with a coded PHY at 125 kilobits per second, the the sensitivity level goes up to 108 dB. So we have a the link budget improvement goes up to 108 dB. So we have a 6 dB improvement in the link budget compared to the 1 megabit per second with the same low current. So if you look at the specification of the device, CC2640R2F, you will see that the receive sensitivity for 1 megabit per second is minus 97 dBm, but it is improved at minus 03 dBm when we apply the new Codit 5 on 125 kilobits per second. So again, I repeat, improved link budget at the receiver level with the same low current. Now, if you look at the transmit side, we said previously that another way to increase the link budget is to increase the output power. So many BLE applications transmit at 0 dBm, and at 0 dBm, the device that we have today here consumes only 6 milliamp. If you increase the output power up to 5 milliamp, we are still able to maintain the power consumption below 10 milliamp, which allows the application to run off typical common coin cell batteries. So one of the key points that we did verify is that with the 2640R2F, when we use the new Bluetooth 5 Codit 5, we can actually achieve a BLE range of more than 1.5 kilometers while still maintaining the peak current consumption below 10 milliamp. So that's a question that we have all the time. Is the power consumption increasing? How does it work? And you need to distinguish the receiver side and the transmit side. But the new Codit 5 enables you basically to still target ultra-low power application based on coin cell battery thanks to the new Codit techniques. So the first test that we did was basically line of sight, outdoor, 1.5 kilometers. We also tested the long range into indoor applications. And maybe some of you did see the Bluetooth 5 live demo that we made, and the video is available today on ti.com/BLE. Those pictures are some extract on the TI headquarters in Dallas, where we have a long spine of 400 meters, where you have basically a typical building automation or closed environment condition with a lot of reflection, a lot of people working. And we were testing both the high speed and also the long range. And you can see here one of our colleagues walking inside the corridor and starting from the station and carrying the peripheral and walking away and achieving 400 meters with still an RSSI number which was very good and enabling to go even longer. So that's very promising. We see many applications that could benefit from the long range. And the good news is that you can actually reproduce and test this demo right away with existing hardware and demo software based on the TI SimpleLink family. So if you want to do high speed and long range, then you can develop on the high speed and test the long range. One question we have a lot as well is, can we have both? Can we have high speed and long range? So precisely, developers will have to make a choice, a decision. We just saw that if you want to implement the longest range, you need to implement the Codit 5 down to 125 kilobits per second. So you will have to make a trade-off and decide for your application, do you need high speed? So we could see that you can change the high speed mode back and forth from 1 to 2 dynamically. And do you need also long range? And you need to have a flexible solution that enables you to change in software dynamically for your application. But you can't have both. You need to choose depending on your condition in order to validate what Bluetooth 5 can make for you. So again, the good news is that we are enabling you today to test those benefits, high speed, and also the long range. And this is available right now. And now we'll move more into the technical details on what we basically offer and how could you start to test Bluetooth 5 for your application. So one of the key points that we did announce in May was the first solution for Bluetooth 5, fully qualified, is based on the SimpleLink wireless microcontroller 2640R2F. And the first part that we did qualify that enables you to develop an application and move to production and qualify it is the high-speed mode. So that's available today on this device. We have a demo available that you can test for the long range. So this enables you to validate for your thermostat application, industrial application, is your environment compatible with the long-range Bluetooth 5, and you can test it on the same platform. One of the benefits of this platform is the industry's smallest flash-based Bluetooth 5 wireless microcontroller with a very small package down to 2.7 by 2.7 millimeters. So it's an optimized solution for end-node IoT applications. And also, part of the spec that I will show in a second, we provide the leading lowest power for the best RF performance. And this is part of also the roadmap deployment with more devices coming up in the next few months. So if you look at the overall architecture for the people on the phone who might not be familiar with the wireless microcontroller, as the name says, it's a microcontroller plus wireless integrated. And this is a simplified overall architecture of the existing solution, where you have a flexible radio. As I mentioned, we developed very closely with the SIP Alliance the long-range mode. Our radio is flexible to implement future mode in the moving forward, and also implement higher speed mode. We have some analog interfaces like a sensor controller that enables you to measure sensor information while the rest of the system is sleeping to maintain overall low power consumption. We have on-chip non-volatile memory and also RAM, different peripherals, and a Cortex-M3 application microcontroller that comes by default with a fully tested TI real-time operating system that enables you to implement complex applications managing different threads. It comes with different packages, including one of the smallest, flash-based MCU package. This device also comes with an automotive qualification, and our platform strategy will ensure that whatever you start today will be software compatible, and in some cases also pin-to-pin compatible with higher memory density devices. In terms of getting started, we will see that we provide now some new curriculum, new examples, new libraries to do your development very quickly and to test Bluetooth 5 quickly, including cloud-based solution that enables you to develop code even if you don't have a target. And also we have modules available through our third-party network providing Bluetooth 5. In all the themes that we discussed, it's all about wireless connectivity. I would like to highlight that the SimpleLink 2640R2F is part of the SimpleLink MCU platform that enables basically developers to leverage their code, tools, resources across many technologies. And one of the key points is moving forward, whatever code you develop today on the Bluetooth Low Energy 2640R2F is 100% reusable for other technology. Maybe tomorrow you will need to look at sub-gigahertz, or maybe sub-gigahertz plus Bluetooth Low Energy, or maybe Wi-Fi. The SimpleLink MCU platform is now using one unique SDK platform software that enables developers to migrate very easily their software with 100% code reuse. So this is reflected also on our TI website. So if you look at our plan for Bluetooth 5, what we have delivered in April, May was the first Bluetooth 5 fully qualified solution supporting the high-speed mode. So this is what is available today, fully qualified, meaning that you can go ahead, develop your application, and develop and qualify your end product. It's based on the SimpleLink BLE platform, and the device today in full production is a 2640R2F. We will implement long-range and advertising extension in a fully qualifiable SDK around October this year. and more options to come along the lines. So again, you can start today your development on the high-speed mode, and you can also test on the same hardware just by downloading a software example, the long range. So if you are waiting to see what is good for me, do I need speed, do I need range, basically with this platform, you can test it immediately. Low power is, of course, very important. It's the essence of the Internet of Things on the endpoint, which are all battery powered. So I just want to reiterate that power consumption and ultra-low power has been thought by design into this device. And you can see here some of the numbers that we talked about with a peak receive current below 6 milliamp while communicating, and an overall ultra-low power architecture that enables to have less than 0.15 microamp in shutdown. And we also mentioned the integrated sensor controller that enables to get information for temperatures, analog, digital sensors, while the rest of the system is sleeping. So overall, if I would have to summarize why 2640 R2F for the automotive version is the right device for your Bluetooth 5. And we have more details on our blogs and on our website. But definitely low power and best RF performance is one of the leading factors for this platform. We are delivering Bluetooth 5 on the smallest flash-based package today available. It's fully qualified for Bluetooth 5, but also supporting Bluetooth 4.2 and 4.1. So we have this question a lot. Even if you have a Bluetooth 5 device, yes, it will be backward compatible and being able to support also the Bluetooth 4.2, 4.1, 4.0. So maybe today you don't need Bluetooth 5. You are just looking for Bluetooth 4.1 or 4.2. Of course, the device is supporting that. One interesting point that I will develop in 1 second is that the ability to plug and add BLE to your application, which is called a simple network processor configuration, and I will give more detail in a second. Another benefit is that we provide a solution for beacons. We also have enough flexibility and performance on our device to also perform voice over BLE. So we do see more and more applications, for example, in the building automation space, where you want to use a BLE link to do voice commands. And certainly, we can see now with the Bluetooth 5 and the high-speed mode, this will continue to encourage those applications. So that's something that is popular today with voice remote control and spanning out now into industrial applications. If you are looking at the Apple standards to control home automated application, you will need the HomeKit standard, and the device is HomeKit certified. Industrial and automotive version are available. And again, this device is part of a larger platform called a SimpleLink MCU, and that is ensuring moving forward software and hardware compatibility for your future development. And last but not least, is part of the SimpleLink MCU ecosystem that enables you to basically invest in some tools that can be compatible with Wi-Fi or 30 GHz or microcontroller only. So if you look back at the purpose of this presentation, it's all about Bluetooth Low Energy adoption for industrial. And we talked about a couple of key points. One reality is that in many cases, for industrial application, the application typically already have a host microcontroller. So we do have a lot of a large choice of host microcontroller for your application. But maybe at this stage, what you simply want to do is to just add BLE on top of your application. You don't know yet if maybe BLE will be suitable for your application. You want to try it. And you don't want to break your full design, you just want to connect Bluetooth on top of your application. So this is possible today with the software configuration that we do propose. And one configuration is called the simple network processor, where basically through a simple SPI or UART, you will talk to the BLE device, 2640 R2 in this case, and this keeps your system very flexible And as we can see in industrial, sometimes there is certification process, qualification process, it takes time. So that's a very simple and easy way to add Bluetooth Low Energy on top of your motor control, on top of your gateway, on top of your sensors, without the need to break your full application and to redo everything. So that's a great flexibility that we provide called the network processor. Depending on your application, if you want to have a more optimized system, and if you are looking at end node application, small size, optimized, then you can look at a standalone wireless microcontroller, where in this case, you will leverage internal microcontroller of the wireless MCU in order to do your application as well. So we call it a single chip BLE system on chip or a wireless microcontroller, basically integrating both the BLE function and the host microcontroller. So two options, depending on your design cycle, depending on your application, that enables you to quickly implement BLE and optimize it moving forward. So in terms of application and expanding, and hopefully you will recognize some of your targeted application on this slide, this is where we do see a great traction for BLE in industrial, ranging from building automation, and today we gave an example of a door lock solution, medical or appliances, asset tracking, and let's face it, there are many industrial applications and that are remain to be defined and to be seen that simply want to connect to a phone or a tablet. You know, if I have an application where I would like to have a display, what about if I build an application where I don't need to break entirely my system, do a new redesign, but just connect to a smartphone or just connect to a tablet to measure temperature, sensors, and so on. Maybe you need speed, maybe you need range. So that's basically what BLE is solving, and in particular with Bluetooth 5, the benefits that you will get from an industrial standpoint in terms of noise, in terms of reduced power consumption, in terms of robustness, in terms of range, and in terms of speed. So how to get started with TI, and here I will give you a couple of key web links. So first of all, if after this webinar you want to try Bluetooth 5, it's very simple. First of all, you need to use our standard tools in TI, which is compatible for any of our wireless microcontroller in terms of interfaces, which is called the Launchpad. So it's an overall default platform that we use that enables anyone to quickly test the software, and that can be connected to some add-on booster pack that comes in different shape and form, like sensor, interfaces, display. So you will then learn to display the Bluetooth stack, which is available on the TI website. And you can see here, based on the Bluetooth 6 Alliance, that we were the first back in April to deliver first fully qualified Bluetooth 5 protocol stack for single-mode Bluetooth Low Energy application. And as I mentioned, what is fully qualified today is the high-speed mode. You don't need to have all the modes to be Bluetooth 5 enabled, and the high-speed mode is the one that we believe is going to benefit many applications quickly in terms of low power, in terms of over-the-air download improvements, and all the things we just mentioned. So all what you need is basically a launchpad and also the software. In terms of software, if you look at the market, many industrial developers are very new to wireless connectivity. And let's face it, wireless can be difficult. So we worked hard to make things easier by developing an overall software environment that will hopefully tailor your needs. One is based on the cloud-based environment. So you don't need to buy and install a complicated debugger on your PC. You can use directly Code Composer Studio in the cloud on TI.com to develop and test what we call the Project Zero. So in this case, no software is really needed. All what you need is a launchpad and internet connection. You can click on one button, you flash a device, and you can follow the instruction to have really a 5-10 minutes out-of-the-box experience talking to your iOS or Android device. And then afterwards, you can go at the next step and import project to the cloud. You can develop, build, debug, and with many examples. So if you go to this web link here, you will see a huge environment of very simple to use projects in order for you to validate if Bluetooth 5 could be a solution for you. Then, depending on your level, we have also some other level of projects like the SimpleLink Academy, which are different training modules that combine both theory and explanation with interactive quiz, and that enables you, for example, to implement a simple network processor. Again, if you have an industrial application, maybe you have already your host controller, you don't want to change anything, you just want to add BLE. How do you do this? The project in the SimpleLink Academy is answering this question. And also, if you want to quickly test some demo, so the long-range demo that we did test in Dallas for the 400 meters is located on the GitHub repository. And all you have to do is to just flash the software on the Launchpad, press a couple of buttons, and it's very easy. And you can, in a matter of minutes, test the long range inside the building, on a parking lot, across offices, and really go and see if this could be a technology solving your application challenges. So developing in the cloud is something that is becoming more and more popular. And again, you don't need to install a full big debugger and start quickly by developing and testing software available for you. So if you look at BLE for industrial, long-term support and is important. I just wanted to give you also a snapshot of where we come from. We have shipped more than 1 billion devices for the past years, more than 15 years experience in a large customer base. So making things easy, robust, tested, simple is very important for us. And we'd love to hear your feedback on your experience. And we do provide the worldwide support 24/7 through our online E2E community, and also with many local offices where you can have a technical sales or a sales representative addressing your question. So wrapping up, today we talked about Bluetooth 5, which is a new standard for Bluetooth Low Energy. It's addressing 4 times the distance, 2 times the speed, and the new advertising extension. We also talked about the random frequency hopping, improvement on the power consumption, the resilience, the coexistence. And if you want to start today on a fully qualified in-production device, the answer is a CC2640 R2F, which is the smallest flash-based Bluetooth 5 solution in the world today, enabling you to do wireless microcontroller or simple network processor with a fully qualified solution today with a high-speed mode, with also a demo that you can use right now to test long range. So if you want more information, you can go on tia.com/BLE, where you can find all the links for the training, the videos, and more information if this, hopefully, webinar caught your attention. So thank you for your attention, and now we'll open for questions. So I will look at the chat and take question on the fly. If we don't have time to answer everything, we'll come back to you anyway. If I need more experts from our side to answer the question, then we will also follow up with our experts. All right, so we have a couple of questions here. So under the same condition, is Bluetooth 5 requiring less power than the Bluetooth 4.2? So yes, we basically have less airtime when we are transmitting for Bluetooth 5. We don't have necessarily a linear ratio when you move from 1 megabit to 2 megabits of dividing by 2 the overall power consumption, but something below 50% maybe could be tested and quantified. But the real technical answer is that it really depends of your system condition and how you are using your system, your environment. If you have a lot of noise, maybe you will need to retransmit anyway. So yes, Bluetooth 5 high-speed mode is providing a lower power consumption, but the real testing in your condition between 4.2 and Bluetooth 5 would be the real and fair technical answer on that. Is it possible to transmit long range in non-connectable mode? So I believe the answer is yes. Our demo actually is providing that on the long range on the GitHub software. I'll take a note, however, to double check the answer with the expert and come back to you. I can see also a question on, is it possible to send advertisement extension 250 bytes in advertisement channel? We take this one and we'll come back to you on this one. So sometimes we have a question on why should I choose Bluetooth 4.2 over Bluetooth 5? And so basically in theory there is no reason not to provide Bluetooth 5 high-speed mode support because it will typically provide a better number in terms of energy consumption. That being said, you will lose some link budget when you go from the process to increase this high-speed mode. So this is something that you have to test also on your application. And but for the long range, really, one of the key points that I mentioned is you will have to decide whether you need speed or range. So the answer on why choosing Bluetooth 4.2 and Bluetooth 5 is a mix of what you really need for your application. And also the good news is it's configurable through software. So you don't need to be at 2 megabits per second all the time, maybe just at the beginning for your application. You don't need to transmit also in long range all the time. So it's flexible and we allow you to do that with our software. Any other question? So we see sometimes a question on what kind of distance can I get when I'm using high-speed mode. So it's basically the same type of, so when you are using the high-speed mode, the typical distance is what we call room coverage, personal area network, so very similar to 4.2. I mentioned as well that if you are using a Bluetooth 5, yes, it can talk to a Bluetooth 4.2, so this is backward compatible. So you don't need to worry about is it the right time to move to Bluetooth 5 or Bluetooth or to stay on Bluetooth 4.2. Is there any other questions?
Go down to the Q&A window. There's a number of them.
Which window?
Yeah, open the Q&A window.
Yeah, sorry, my PC just froze.
Okay.
Oh, hold on, Q&A. So I can see here questions here. Is it possible to connect with BLE Mesh network? So the BLE Mesh, so Mesh has nothing to do with Bluetooth 5. That's the one question we have in many cases. The Bluetooth Alliance will release the Bluetooth Mesh software shortly during this summer. And when it is available, TI will propose a plan to deliver the Bluetooth Mesh. But again, Bluetooth Mesh is not connected to the standard itself. It's something on top of it. So we certainly envision that benefiting from Bluetooth 5 and Mesh will be possible into the future. Yes. Coexistence with TI Wi-Fi sampling products on the 3200. So we have many developers who are trying to develop optimized gateway doing BLE to Wi-Fi, and there is a coexistence challenge between these two devices, between these two technology, Wi-Fi and BLE, where into this 2.4 gigahertz solution. We do have third party who implemented a coexistence mechanism, and TI is working on one solution. And we could share with you the plan more in details, but that's something that we are currently looking at, yes. But it's not automatic. You need to implement the software. So there is a development effort here that we are looking into. Can we update the CC2650 based sensor tag with Bluetooth 5? And the answer is no. The first device supporting Bluetooth 5 is a CC2640R2F. So the good news is that the two devices are pin-to-pin compatible. And you could actually make a switch here, but to answer just the question, no, 2650 sensor tag is not Bluetooth 5 capable. And right now there is no plan to do a sensor tag based on the 2640 R2F. So the recommendation we have to start development and to make some testing on Bluetooth 5 is really to use the Launchpad. And if you want to have sensors quickly connected to Bluetooth 5, we do have a booster pack that provides many sensors, temperature, and so on that you can connect on top of the Launchpad to have similar benefit in terms of IoT ease of use and experience compared to the sensor tag. Can you talk shortly about localization and using BLE and iBeaconing? So we do have actually many examples into our customer base of beacons providing locationing information, directions for stadium, airport, and indoor application. So it's a mix of is the radio capable to provide locationing function, and it's a mix also of software available. So the good news is that our radio is flexible enough to provide more advanced locationing function, and the software will be provided moving forward into our SDK, and we could share more information if you contact TI on that. I heard that Cisco routers are supporting BLE. Do you know which routers support that? No, I don't know. Is there any other questions? I'm looking at the frequently asked question that we are more questions here. Is there a reference design using the 2640 R2F? If so, where are these found? So yes, we do have a reference design where we provide a fully optimized BOM on how to use the 2640 R2F. First, if you look at the Launchpad as a schematic, the BOM is available, and we also provide some reference diagram in order for you to optimize your solution. You will see that one great benefit of the 2640 R2F is that if you want, you can remove the 32 kHz crystal that's pretty unique onto the market, which is optimizing your BOM, and we are providing guidelines on that. So short answer, TI.com/BLE, you will guide you through all those information, and you have also the online E2E forum that will point you to the right direction if you have some more questions. Which tool do you have? Do you have to develop? Really what you need is a hardware tool, which is the Launchpad I just mentioned. And as a start, you can use our integrated development environment called CCS, which is in the cloud. So for the first step, you don't need to invest anything. Just get a Launchpad for $29, and you can connect directly to the cloud through the TI web on some example in order for you to quickly evaluate. And once you want to develop more, you can develop and download our IDE, which comes for free. So the investment is really minimum. So this is described on the Getting Started tab for the TI.com/BLE. Do we have any documents or videos for technical details that can help with coding? So the answer is yes. And I will just go back here you need to look at tia.com/BLE wiki. We have what we call SimpleLink Academy, which are step-by-step guided examples that helps you to implement real-time operating system tasks, BLE services, sensor controllers, so many examples that will help you. Plus, on Turnitin.com, we have some videos on how to get started, and we have a video for every Project Zero. So please have a look at that, and we'd love to hear your feedback on is it enough, is it good enough, and we want to hear from you on that. So where you can find it, so those links here are some of the key links. This presentation will be available anyway, also online, so you can refer. But if you are lost, tia.com/BLE. Can we use the BLE? It sounds like the last question is, can we use BLE to know what is the distance in meters from iBeaconing? I'm not sure about this one, and I will need to ask our expert to give you a correct answer. But I know that for locationing function, many developers are looking for distance measurements and precise locationing down to the meters, centimeters. So I suspect the answer is yes, but I will circulate back with our technical experts to give you the right answer. All right. So with that, we are already closing the hour. So if you have more questions, please continue to post, and we'll be happy to answer. I think, Randall, this presentation will be loaded on the Element 14 Farnell website, and we will continuously make sure to address your questions moving forward. Again, tia.com/BLE, and also our E2E forum will be the right venue to answer your question to start on Bluetooth 5. So with that, I thank you for your attention and wish you a good day. Thank you. Bye-bye.
That concludes today's webinar. I'd like to thank Olivier for delivering an excellent presentation. I'd also like to thank everyone who has taken the time out of their busy day or evening to attend.
Bye-bye.